At this level of dietary restriction, the human body normally starts dismantling itself, trimming functions, shedding tissue, rationing energy until something critical fails. And yet, the process stalls. The collapse does not arrive on schedule. The contradiction appears only after the system is already running, after weeks pass without organ failure, after blood chemistry stays unreasonably stable. The source is not a supplement, not a laboratory formulation, not a designed survival ration. It is a potato. Not an enhanced one, not processed, not fortified, just the underground storage organ of a plant whose only evolutionary goal was to survive winter long enough to grow again. From a biological perspective, this is deeply uncomfortable. Human nutrition is supposed to be redundant, layered, dependent on variety, buffered by excess. Remove that variety and deficiencies should stack quickly, compounding into systemic stress. But the potato resists that expectation. Calorically, it supplies glucose at a rate slow enough to avoid insulin chaos, yet steady enough to keep neurons firing. Its starch structure breaks down predictably, producing energy without spikes, without urgency, as if the metabolism has been placed on a dimmer switch rather than an on-off button. Micronutrients appear just barely in time. Vitamin C exists at levels that do not signal abundance, only absence of failure. Potassium concentrations hover near the minimum required to prevent electrical instability in muscle and heart tissue. B vitamins linger in quantities that keep enzymatic pathways open. Not comfortable, just operational. Nothing about this composition suggests optimization for humans, and that is where the unease grows. This is not a food designed to nourish a large primate with an energy-hungry brain. It is a biological battery for a plant embryo, and still, the human body adapts around it, lowering metabolic expectations, slowing turnover, reallocating resources with clinical indifference. Lean mass decreases but does not vanish. Blood markers drift but rarely cross into emergency. Hunger persists, but it becomes dull, manageable, almost procedural. The system is not thriving. It is stabilizing at a lower resolution, like an image rendered with fewer pixels but still recognizable. This is where the horror quietly lives. Survival here is not protected by resilience or strength, but by coincidence. The potato happens to sit at an intersection of biochemical needs narrow enough to support life without supporting safety. There is no surplus, no cushion, no forgiveness. The body operates with its tolerances tightened, its margins shaved thin, its error bars compressed until variation itself becomes dangerous. Any disruption, a missed mineral, a slight illness, an increase in demand, would have nowhere to be absorbed. And yet, as long as conditions remain static, the organism continues. Not because it is well fed, but because biology allows existence at levels far closer to failure than intuition suggests. The potato does not keep humans alive because it is perfect. It does so because perfection is not required, only adequacy, sustained long enough to feel wrong. Energy is usually where restricted diets fail first. The brain alone consumes roughly a fifth of the body's resting energy, an inflexible demand that does not negotiate when intake drops. Muscles can be downsized, immune response is delayed, reproduction shut down entirely, but neuronal metabolism stays greedy and precise. Under normal conditions, removing dietary diversity creates fluctuations, glucose rises and crashes, stress hormones spike, the system becomes noisy. With potatoes, that noise is strangely muted. The calories arrive without urgency. Starch granules, once cooked, unravel into glucose chains at a pace slow enough to avoid panic, yet fast enough to meet baseline demand. It is not abundance, but it is continuity. The liver refills glycogen quietly. The bloodstream carries fuel that never quite feels sufficient, yet never fully disappears. From a survival standpoint, this is unsettling. This level of metabolic calm usually requires careful engineering or complex food matrices. Here, it emerges from a plant structure meant to sit underground and wait. The paradox deepens when considering total intake. Potatoes are volumetrically large, energetically modest. To meet daily needs, the digestive system must stay active for long stretches, processing mass rather than density. The gut works continuously, not aggressively, just persistently, extracting glucose, potassium, water. This creates a rhythm that mimics food security even when variety is absent. Hormonal signals interpret this as stability. Cortisol stays restrained. Thyroid output may soften, lowering overall energy expenditure but not enough to trigger alarm. The body quietly agrees to operate in a reduced power mode. This is where the lack of permission becomes clear. Human physiology was not granted a single staple fallback. Evolution favored flexibility, omnivory, redundancy. And yet, faced with this monotonous input, metabolism does not rebel. It complies. fat stores decrease at a controlled rate. Ketosis remains mostly unnecessary because carbohydrates, however plain, continue to arrive. The system avoids extremes by accepting mediocrity. The discomfort lies in how little protest there is. One would expect headaches, dizziness, cognitive fog. Instead, mental function often remains intact, not sharp, but usable, as if the brain has recalibrated what clarity means. This reveals an uncomfortable truth. The human body does not require rich energy sources to function. It requires predictable ones. Potatoes provide predictability without permission, energy without intent, fueling a primate brain on the byproduct of a plant's survival strategy. There is no generosity in this exchange. The calories are not offered. They are taken, stripped from a structure never meant to support this level of demand. And still, the system holds, not because it is healthy, but because biological engines are designed to keep running even when the fuel is barely acceptable. Protein deficiency is supposed to be obvious. Muscle wasting, immune failure, impaired repair, enzymes falling silent as amino acids run out. This is the failure mode textbooks describe when diets rely too heavily on starch. And yet, when the primary food is a potato, that failure often delays itself. The numbers do not look reassuring. Protein content is low, nowhere near what is considered optimal, nowhere near what athletes, clinicians, or dietary guidelines recommend. But biology does not ask for optimal, it asks for minimums. Potatoes contain all essential amino acids, not in generous quantities, but in a complete pattern. Lysine is present. Methionine exists, though limited. The ratios are imperfect, but they are not broken. Consumed in sufficient mass day after day, they accumulate into adequacy. The body responds by changing strategy. Muscle protein synthesis slows. Turnover rates decrease. Non-essential processes are postponed. Structural proteins are preserved not because resources are abundant, but because degradation becomes more dangerous than conservation. This is a quiet shift, invisible from the outside. Weight loss may occur, but not collapse. Nitrogen balance hovers near zero, not positive, not catastrophic. The immune system remains functional but cautious, responding without excess, producing antibodies slowly, efficiently, without waste. From a survival perspective, this is disturbing. The human body is capable of operating on protein rations that feel mathematically insufficient. It achieves this by reducing ambition. Growth stops, repair becomes selective, adaptation replaces improvement. The unsettling part is how sustainable this state can feel. Weeks pass. The body composition stabilizes at a leaner, quieter equilibrium. There is no dramatic signal announcing danger, just a persistent sense of limitation, as if the organism has agreed to exist within narrower boundaries. This reveals a fundamental property of human biology. Structural integrity does not require abundance, only continuity. As long as essential amino acids arrive in the correct pattern, even in small amounts, tissues can be maintained in a holding pattern. The potato does not build strength, it prevents disintegration. And that distinction matters. Survival here is not about thriving, it is about delaying entropy. The protein content is enough to keep enzymes folded, enough to keep transporters embedded in membranes, enough to keep muscles attached to bones. Nothing more. This is why it feels wrong. A food so limited, so unremarkable, should not be able to support the molecular scaffolding of a complex animal. But it does, by exposing how low the true floor of biological maintenance really is. Deficiency does not arrive loudly, it approaches as drift. Reaction times slow first, then connective tissue weakens, then the immune system begins to misread signals. Vitamins are not fuel, they are permissions. Without them, reactions stall even when energy is present. A diet built on a single food should exhaust these permissions quickly. With potatoes it does not, at least not immediately, and that delay is the problem. Vitamin C exists just above the threshold that prevents scurvy, not enough to promote resilience, only enough to keep collagen synthesis from collapsing. Capillaries hold. Gums remain intact. Wounds close slowly, but they do close. Thiamine, riboflavin, niacin, present in modest amounts, keep carbohydrate metabolism from backing up into toxicity. Enzymes continue to function, not efficiently but correctly. The nervous system stays electrically coherent. There is no sharp boundary where health ends and pathology begins. Instead, the body operates in a narrowed corridor where everything works, but nothing is buffered. Fat-soluble vitamins reveal the tension most clearly. Vitamin A exists, but conversion from beta-carotene is variable, dependent on genetics, fat intake, absorption efficiency. Vitamin D is absent unless sunlight compensates. Vitamin E is limited. Vitamin K hovers low. The system compensates by slowing turnover, reducing oxidative processes, minimizing unnecessary clotting events. This is not safety. This is austerity. The unsettling realization is how long this state can persist without triggering obvious failure. Blood tests might look passable, symptoms remain nonspecific. Fatigue, cold intolerance, slower recovery, nothing diagnostic. The body hides its deficits by lowering expectations. It becomes metabolically conservative, avoiding activities that would expose weakness. From the outside, this can look like stability. Internally, it is tension held constantly at the edge of insufficiency. One infection, one injury, one increase in demand, and the math stops working. There is no reserve to draw from. This is where the horror sharpens. Potatoes do not nourish with generosity. They ration survival. They provide exactly enough cofactors to keep biochemical doors from closing, but not enough to reinforce the hinges. The human organism accepts this arrangement without protest because evolution prioritized persistence over comfort. As long as reactions continue, even barely, the system considers itself viable. The danger is not that deficiency appears quickly. It is that it does not. It waits, silent, until circumstances change. And when they do, there is no warning phase, only sudden failure, because the body has been operating at the edge of vitamin adequacy the entire time, mistaking survival for safety. The potato's usefulness ends the moment it tries to live again. When conditions signal growth, light, warmth, time, the chemistry shifts. Solanine and related glycoalkaloids begin to accumulate, not as a flaw, but as a defense. These compounds exist to deter insects, fungi, animals that would consume the tuber before it can complete its life cycle. For humans, the margin between food and toxin is uncomfortably narrow. In small amounts, glycoalkaloids are usually tolerated, metabolized, ignored. As concentrations rise, they interfere with cell membranes, disrupt ion channels, and irritate the nervous system and gastrointestinal tract. The symptoms are not dramatic at first. A bitter taste, mild nausea, a sense that something is wrong but not yet dangerous. This is the same pattern seen throughout this system. Failure announces itself softly. Green skin, sprouts, damage. These are not cosmetic changes. They are biochemical warnings. The potato is no longer a passive storage organ. It is actively defending itself. From a survival perspective, this transition is deeply unsettling. The same object that can sustain a human near the edge of nutritional adequacy can also push that system toward collapse if consumed at the wrong stage. There is no clear boundary, no universal safe line. Solanine levels vary by cultivar, by storage conditions, by light exposure. Cooking reduces some risk, but does not neutralize the compound entirely. The human body, already operating with thin nutritional margins, becomes more vulnerable to disruption. Nerve signaling can be affected. Heart rhythm can destabilize. Gastrointestinal distress can impair absorption, turning a marginal diet into a failing one almost immediately. What makes this unsettling is not the presence of poison, but its timing. The toxin appears precisely when the potato is no longer meant to be eaten. Biology enforces its boundary without regard for human need. The plant prioritizes its continuation over the consumer's survival. And the human body, accustomed to extracting just enough from this food to persist, is suddenly confronted with chemistry that does not negotiate. This reveals a broader truth. Survival strategies often contain built-in termination points. They work until they do not, and the transition is not gradual. The potato does not become slightly worse food. It becomes something else entirely, and a body already balanced at the edge of adequacy has no capacity to absorb that shift. The same system that tolerated monotony, deficiency, and austerity now fails quickly because one variable changed, not dramatically, just enough. What remains after all of this is not admiration, but discomfort. The potato does not represent an ideal human food. It represents a lower bound, a demonstration of how little is required to keep a complex organism running without triggering immediate failure. Calories arrive just fast enough. Protein appears just complete enough. Vitamins persist just above deficiency. Toxins stay absent only while the plant remains dormant. Every parameter sits close to a threshold, never crossing, never retreating. This is not balance. It is suspension. The human body adapts to this arrangement because it has no choice. Metabolic rate declines. Turnover slows. Repair becomes conservative. Nothing accelerates unless forced. The system behaves like an engine, idling in neutral, consuming fuel, producing heat, but never engaging higher gears. From the outside, this can look like success. Weight stabilizes. Blood markers remain acceptable. Daily function continues. But there is no safety margin anywhere in the design. Any increase in demand, physical exertion, illness, injury, cold, psychological stress immediately exposes how tightly tuned this survival state is. There is no stored excess to compensate. The potato does not allow recovery, it only allows continuation. This is the quiet horror embedded in the biology. Humans like to believe survival requires robust solutions, strength, redundancy, resilience. In reality, biology often accepts fragility if it is consistent. A system can run indefinitely at the edge of failure as long as conditions remain static. The potato reveals this without drama. It shows that the human organism can exist in a state that feels wrong because it is wrong, not in the sense of error, but in the sense of risk. This is existence without insurance. The moment the environment shifts, the illusion collapses. The body does not break because it was weak. It breaks because it was never protected. The potato does not threaten human survival. It exposes how close to collapse survival is always allowed to be.